thing about section 7.4 is that for those of you who like a formula and a set way that you do every problem, and that's what you like about math, that's not necessarily what's going to work here. Okay? Here, for those of you who like just starting to do stuff without knowing how it's going to end, like maybe if you're an author and you start writing a novel and you don't know how it's going to end and you figure it out as you go along, that is what we're doing here on these problems sometimes. Okay? So, does anybody want to be a murder detective when they grow up? All right, cool. So that's what we're going to be doing today. We are going to be, we're going to pretend we're detectives, and we know what we're trying to prove, but we have to figure out how to get there. All right? So if you like that, that's what we're doing. Here we go. I'm going to call these examples, just basically, some of you rolling your eyes at me. Establish an identity, okay, is what most of the problems say, okay? So the directions are pretty much the same for almost every problem you're doing. There's a few at the beginning that ask you to do specific things, but then starting with the fourth problem, the rest of them are just all establish an identity. So they're going to give you something like this. Cosecant theta times tangent theta and you are supposed to get from there to secant theta somehow. Okay? All right? So, a lot of times we don't know how we're going to get from the beginning to the end, like I said. But we do know stuff, so we start doing stuff that we do know, and then eventually we see how to get there. So for instance, what's something that you know and you think, I wonder if this would work, or if this would be helpful? Avery. Right. Cosecant's 1 over sine. Let's just write that and see if that helps us. But Avery, what else do you know about tan? All right, let's write that and see what happens. Okay, so make sure on these problems you start with one side, okay, and not the other side. Okay, and you just try to end with the other side. So now I went from here to here, and now you can see the signs cancel, right? So most of you see it now, don't you? 1 over cosine theta, and now 1 over cosine is secant, so we got to our answer, equals secant theta. All right, so that's the answer. Now, we knew the answer was secant theta. Okay, they're telling us where we need to get to. We just have to figure out how. So when I do these, here's what I write for an answer. Got it. So that's what I'll be writing tomorrow for all of the answers. I can't really write all the steps on the board. So you guys just have to work at it. Listen. You'll all be able to get them if you spend enough time. It'll take some of you more time than others, okay? But if you are patient enough, you'll eventually get it. You know where you have to end. You just have to do math until you get there. Yes?
Are there going to be any where it's solving both sides to get to the same thing? On this assignment?
Solving both sides to get to the same. Oh, like where you have two sides and you try to get somewhere else for both of them?
Yeah.
Nope, it's just going to be more like this.
Okay.
Okay, let's try this one. Sine squared negative theta minus cosine squared negative theta over sine negative theta minus cosine negative theta. Okay, that's where we're starting. And we're ending somehow at cosine theta minus sine theta. All right. Now, just so you know, when you see something like sine squared negative theta, what that really means is negative sine theta squared. Okay? So that means the same thing right there. And so we know once you square this on our next step, it's just going to be sine squared because the negative squared will be positive. Okay? Now on cosine, you could think of it either way because on cosine, you could take the negative out anyway, right? Instead of pulling it out front. So I could just right away say cosine squared theta over, so same thing here. On the bottom, we need to pull the negative out because that's what the even odd property tells us to do with sine. So negative sine theta, but for cosine, we're just going to take it away. So this is still minus cosine theta. All right, so I just wanted to do that part kind of first with you and know that negative sine theta squared is sine squared theta. So now this is what I have. Sine squared theta minus cosine squared theta over negative sine theta minus cosine theta. So somehow I need to get from here to cosine theta minus sine theta. Okay? So think to yourself about what the next step might be. And I'm going to use one of my detectives here to summon. See what you think. Do you have an idea yet? Jersey. That's plus. Sine squared plus cosine squared is 1. You can't do it with minus. Okay. How about a thought from Marissa? Okay. How about from Melody? Eli. Carter. Connor R. Avery. Will. Lexi. Owen.
Difference of squares.
Okay? Sine squared minus cosine squared is a difference of squares, right? It's a difference of two squares. You could factor it. Let's factor it. Okay, so I'm going to go right here. Sine theta plus cosine theta, sine theta minus cosine theta. It's just like x squared minus 4, x plus 2, x minus 2. Same thing. Okay, what you cannot for sure do is, I was waiting to see if someone was going to say, cancel this sign with one of these. Okay, you can't cancel things that are being added or subtracted, so that would not have been mathematically correct. This is the way to go right now. Okay, so do you have an idea, now that we've done that, do you know what to do on the bottom, Alex?
Cancel?
Well, almost. What will allow you to cancel first? How about Shannon?
Take out a negative 1 on the bottom, so then it is sine theta plus cosine theta, and you can cancel that on top.
Yes. Because you can't cancel sine minus cosine with negative sine minus cosine, or the plus. But if you pull out a negative 1 on the bottom, then it becomes sine theta plus cosine theta, and now we can cancel this first one on the top. Okay, so those two will cancel, leaving us with sine theta minus cosine theta over negative 1. And at this point, we're pretty much there, right? Because if you divide by negative 1, it just flips the signs. So now the sine will become negative and the cosine will become positive. So I could just write it like that. Cosine theta minus sine theta, and I got to my answer that I needed. Cosine theta minus sine theta. Got it. Okay, so some take a little longer than others. I've got 4 more examples. Trying to cover lots of different things that could happen, but every problem's a little bit different. So it's hard for me to totally cover everything. But what I can tell you is the book gives you some things to think about as you're doing these problems, because there isn't a set method that's the same all the time. So this is on page 475. It gives you these 4 guidelines. It's almost always preferable to start with the side containing the more complicated expression. Okay? So technically, you don't have to start with the left side and try to get the right. You could start with the right and try to get the left. It doesn't matter either way, but usually, whichever side has more stuff, it's easier to go from that side to the side with less stuff. Because if you start at the side with less stuff, there's just not as much information there for you to know what to do. Second hint, rewrite sums or differences of quotients as a single quotient. So if you have fractions being added or subtracted, it's usually helpful to put that together and just make it one fraction. Okay? Sometimes it will help to write one side in terms of sine and cosine functions only. So if you got a bunch of different stuff like secant and cotangent and cosecant and all those things, and there's just too many different things going on, sometimes you write it all as sine and cosine, and that might help you figure out what to do. And of course, just always know as you're working, where are you trying to get? Okay? Because as you start, you usually don't know how you're going to get there. So always take a look at it as you're going. Okay, let's try this one, C. Let's go 1 plus tangent u over 1 plus cotangent u, and see if we can get that to just tangent u. All right, so as I look at this, we know that where we're trying to get to only has tangent. And by the way, yeah, you could start here and try to get here, but that'd be tough. You wouldn't know what to do with this. So we start with the one that has more stuff usually. Okay, but anyway, since my final answer has only tangent in it, that's probably what I want to deal with first. So Matthew, what do you think I should do first? But in this particular one, even though that's one of the hints, this particular one only has tangent in the answer, so I wouldn't necessarily start putting them into sines and cosines, because then I'm just going to have to put them back into tangent later. So how about Avery? Turn cotangent into 1 over tangent. That's what I would do first. Yep. Thank you. All right, so let's do this. 1 plus tangent u over 1 plus 1 over tangent u. Okay, now the next step is going to utilize kind of one of those hints that they gave. It's raining. Chris, do you have an idea what to do next? Okay, that's all right. The next step is algebra. Okay, it's manipulating something with algebra. How about Marissa? Brant. Okay, Holly. Carter. Okay, come here. How about Chris? Okay. Oh, you have a note.
Do I have to go right now?
Yeah, it said.
Take the 1 and make it 10 u over 10.
Yeah. Okay, so one of the hints it said is rewrite sums or differences of quotients as a single quotient. That might be the whole thing is sum or difference of fractions, or just looking at the bottom right here. I would rather just have one fraction on the bottom of this fraction, not two things added together. So that's what you want to do. Does everybody understand that 1 is tan u over tan u? If I want to get common denominators here, this is tan u over tan u plus 1 over tan u. So if I put it together, it's tan u plus 1 over tan u, right? That's how I'm going to rewrite the bottom. So leave the top the same, 1 plus tan u. And on the bottom, let's write tan u plus 1 over tan u. And I think if you look at that now, most of you are going to start to see how we're going to finish this one. And I will just have Avery tell me again, how will I finish this now?
So you can just move 10 u and then really just cancel it.
Because I'm going to do what?
Just cancel out the 1 plus 10 u on the top and 1 plus 10
Right, because really I'm going to do this divided by this, so I just need to multiply and flip it around. That's what you mean, right? 1 plus tan u, I think of this top as 1 plus tan u over 1, and I think of this bottom, flip it around, tan u over tan u plus 1, and now those will cancel out, leaving us with tan u. Okay? This just takes practice. The more you do, the more you'll see these little tricks, unfortunately. Congratulations, you have completed participation requirements. Okay, let's go to D. Let's try sine theta over 1 plus cosine theta plus 1 plus cosine theta over sine theta. And I want to somehow get that to be 2 cosecant theta. Okay? So you almost need to be a genius to see how to start this problem. Or I mean, not how to start it, but how you're going to get all the way right now. Okay? There's a lot going on here, so don't feel like you have to know. All right? What just happened? Okay. Just know that you want to do something. Okay? And that something could be dealing again with rewrite sums or differences of quotients as a single quotient. Okay? We've got two fractions added together here. It will probably be easier if we could just make that one fraction all written together. Okay? So, what's our common denominator here? Both of them, yeah. 1 plus cosine theta sine theta. So I'm going to rewrite this 1 plus cosine theta sine theta. 1 plus cosine theta sine theta. All right, this went from 1 plus cosine theta to 1 plus cosine theta sine theta. So we multiplied by sine theta. Now you got to do it on the top. Sine squared theta. Same thing here. Here we went from sine on the bottom only to not only sine but also 1 plus cosine. So we need to put another 1 plus cosine on the top. Or in other words, just write 1 plus cosine theta squared. Okay, so now it's just a matter of writing this as one fraction with a common denominator of 1 plus cosine theta times sine theta. Okay, and I'm going to add the tops together and just write it as 1. So I've got sine squared theta plus, I'll just write this, 1 plus cosine theta squared. So here's the thing. Can I cancel this 1 plus cosine theta with one of these? No. You can't do that. Mathematically doesn't work. You can't cancel things that are being added. So instead, really the only option for us, we still don't, most of us don't know how we're going to get to the end. I only do because I did this first block. But at this point, I would not expect you to know how this is going to end yet. But the only thing you could do is sit there and look and say, well, what's something I could do? I could FOIL this out, see what happens. Okay? So that's what you should do. All right? You can't cancel anything, so let's just try FOILing it out. Keep this sine squared theta plus, all right, try to FOIL this out. 1 plus cosine times 1 plus cosine is 1 plus 2 cosine theta plus, and then cosine times cosine is cosine squared theta. And keep the bottom the same for now. Now I'm going to call on somebody to tell me what to do next. I think some of you see it. How about Connor T? Eli?
Pass to the person with the least amount of participation points.
Hey, Anthony.
Minus sine squared plus cosine squared to make 1.
Yes, you do. Hey, it's the second straight day that's happened, but he's got it. So he just hasn't been called. I haven't called his name as much this semester as some of the rest of you. So, it's just something the calculator has against him. Sine squared plus cosine squared is 1. Let's make that a 1. Add this to the other 1, and I've got 2. So I've got 2 plus 2 cosine theta over 1 plus cosine theta sine theta. Oop. So now I'm really getting close. What should I do next? JC. Brandt.
Could you get rid of the 1 plus cosine theta and the 2 plus 2 cosine theta?
How?
Just by like crossing them out?
You can't just cross them out at this point. There's something you would have to do first. Okay? So what is that thing? Shannon.
Pass to will.
Take out a 2 on the top, then it will be 1 plus cosine theta. Then you'll definitely be able to cancel it with the bottom. 1 plus cosine theta sine theta. The 1 plus cosines cancel each other. And finally, we have 2 over sine, which now you see how we get to 2 cosecant, because it's 2 over sine. 2 cosecant theta. Got it! Congratulations, you have completed participation requirements. Okay. All right. So that one was the biggest one that I have. Okay? All right. But I do have 2 more. this is another one. A different case that you need to think about. How about tan V plus cotangent V over secant V cosecant V? Okay, so you've got all those different things there, and we want to get to 1. So, you don't know how you're going to get there, but you might have an idea where to start. Oh, it's calling on Shane. Shane.
Change the bottom in terms of cosine and sine.
So the bottom.
Yeah, so change it to 1 over cosine V.
Mm-hmm.
1 over sine V. Then we say cotangent on
And the tangent.
top. Yeah.
I mean, really, we could do everything in terms of sines and cosines. Then we wouldn't have as many different trig functions, right? So then the top would be
Sine of V over cosine V plus cosine V over cosine V.
there. You have that. Okay, so you might still not know where this is going, but at least you have something to start with. Okay, so now just look at the top, and you should know that our method next is always to put two fractions together and make them 1. Okay, so let's do that here. What's the common denominator of the top? Both of them, right? Cosine and sine. Cosine V, sine V. I'm just going to try to do this all at once. Hope this is okay. Cosine V, sine V is the denominator of the numerator, right? The denominator of the top. Cosine V, sine V. So here it was sine V. Now it's cosine V, sine V. So I have, So it was cosine. Now it's cosine sine. So they multiplied by sine, so we need to multiply the top by sine. Sine squared V plus, same thing here, they went from sine to cosine sine, so they multiplied by a cosine. We need to do the same, cosine squared V. Okay, hopefully that algebra made sense. Now the bottom's just multiplying, so we can just multiply straight across, call it 1 over cosine V sine V. Now we can, sine squared plus cosine squared is 1, right? So we got 1 over cosine sine over 1 over cosine sine. Copy, change, flip. 1 over cosine sine times cosine sine over 1. Yes, that's equal to 1.